Under a microscope, blood can be seen flowing in some of the small blood vessels. It consists of a pale yellow fluid in which float many red and white corpuscles. Most of those you are looking at in this drop of blood are red ones. There are 500 red corpuscles to every one white, and so it is not so easy to find the white ones among the red. The fluid in which the corpuscles are floating can be separated from the solid part of the blood. This is done by an apparatus known as a centrifuge. Blood is poured into a small glass tube, which is put into one of the 4 cups of the centrifuge, which is then made to spin very rapidly. This spinning separates the lighter fluid part, which comes to the top, from the corpuscles, which are heavier and settle at the bottom. Here are the red corpuscles again. They are so small that there are an enormous number of them in a tiny drop of blood. Here is a white cube which represents 1 cubic millimeter. You can see it is about the size of a pin's head. In 1 cubic millimeter of blood, there are 5 million red corpuscles. The penny gives you some idea of how small a volume a cubic millimeter is. This is part of a crowd of about 90,000 people at a football match. It would take more than 50 such crowds to make 5 millions. And yet there are 5 million red corpuscles in 1 cubic millimeter of blood. The corpuscles have to be so very minute to pass along the smallest blood vessels. And because they are so tiny, there must be an enormous number of them to carry oxygen, enough oxygen that is, round the body. Now this diagram shows what happens when we breathe in air, which I hope you'll remember contains oxygen. You see, the oxygen gets taken right down into the air pockets of the lungs. But blood also gets to the lungs. It comes to them from the heart through the pulmonary artery. In a closer view of the lungs, you can see that the artery breaks up into tiny capillaries which make a net over the air pockets in the lungs. Here is a close view of one of the pockets. The round grey things are the red corpuscles travelling round in its blood vessels. Now the pocket is cut across. Air containing oxygen comes into the pocket. This oxygen is absorbed by the red corpuscles of the blood circulating round the pocket. The oxygen is then carried off to the rest of the body. The body is largely built up of cells. Here are red corpuscles loaded up with oxygen arriving at some of the tissue cells of the body. The corpuscles give up oxygen to the cells, and they then go back through the heart to the lungs to take up some more oxygen. Here again is the drop of blood seen under the microscope, and a white corpuscle is now being shown up among the red corpuscles. White corpuscles are colourless and in fresh blood not very easily seen, so this one has been stained to make it show up among the red. The white corpuscles have their own special work to do. They help to defend the body against germs. When you cut or scratch yourself, an opening is made in the skin, through which poisonous germs can enter. If this happens, white corpuscles come quickly up to the danger point to protect the body. Here you can see 2 of them. They destroy germs by flowing round them and engulfing them, very much as an amoeba swallows its food and disposes of it. You can see on the left of the screen how something is being swallowed by an amoeba. More than half our blood is made of a liquid which is called plasma. Like most living things, plasma and corpuscles contain a great deal of water. A potato looks solid enough, but if it is cut up and put into a press, a great deal of liquid can be squeezed out. If the little girl filled a cylinder up to the 200 mark, and she could be squeezed like the potato, enough water would be collected to come to the 132 mark, because about 2/3 of her body is made up of water. Water is necessary for chemical changes in the cells. This powder lies quite peaceably in a beaker so long as it is dry. But if some water is poured onto it, a special kind of chemical change takes place and it bubbles. The water necessary for chemical changes in the cells of your body is brought to them by the plasma of the blood. When the tissues of the body use oxygen in burning foodstuffs, carbon dioxide is made. The plasma picks up this carbon dioxide from the tissue cells and carries it back to the lungs, where it is breathed out. Now, do you see? That is the carbon dioxide supposed to be coming out. A curious thing about plasma is that though the plasma makes the blood fluid enough to flow along the blood vessels, it also helps to stop the blood flowing out from a cut vessel. Now some fresh blood is poured into a glass tube, which is then put into a beaker of warm water. In about 2 minutes, you will see the blood has set solid, because the plasma has changed into a jelly. When blood is shed from a cut or a scratch, the plasma changes in this way, and so the cut in the blood vessel is quickly blocked up.